example B. Okay, I have the difference here. I've got cosine, cosine, sine, sine, so that's all set up. My first angle is 3t, 3t, t, and t, so that all works. The only difference is I've got these 2's in front. Well, there's two terms, both with 2 in the front, so let's factor that out. We don't need it there, and this way it can kind of get us closer to really looking at what we want to solve this problem. Okay, and then we can just kind of divide it off the front, move it over here. So it's saying cosine of 3t, cosine of t, plus sine of 3t, sine of t is equal to the square root of 2 over 2. And again, this is our cosine formula, where the first angle is 3t, the second angle is t. Since there's a plus sign in the middle, we're actually going to connect it with a minus, and the square root of 2 over 2. So what this problem really is asking us to find is, when does cosine equal the square root of 2 over 2, and specifically for 2 rotations. Okay, so for 2 rotations, the square root of 2 over 2, we're doing in radians, and cosine's positive in 1 and 4. So we're looking at pi over 4, and see 1, 2, 3, gotta do this in my head, 4, 5, 6, and 7 pi over 4. Hopefully y'all are trying to do this in your head a little bit too. Gives you better practice. So here's for the first rotation, those 2. And every time we want to keep going, we just add on 2 pi to each of these 2 values. So we're going to have 9 pi over 4, and then 15 pi over 4. And to finish this up, let's just divide everything through by 2. And what that's going to do is make all these denominators, instead of 4's, we have 8's. 9 pi over 8 and 15 pi over 8. Box that up, and we have finished our last problem for that one. Okay, let's move on to example 6. So for the following, we want to show that the left side of each equation equals the right side. Looky here, we have some more of those identities that we did in 8.2. So this is what I was trying to tell you guys, is that it's really important that you spend a lot of time in 8.2 working with those identities, because every time we introduce a brand new one, like in this, for example, in this section, we're going to be doing nothing but not only practicing with them in equation form, solving equations, but we're also going to be using them to help prove other identities. Okay, so right here at the top, we want to show that this left side equals this right side. Okay, and right away, the first thing that pops out of that I see is up here on the top of this first fraction, I have an angle that's x plus y. All my angles over here on the right are just single x's and single y's, so that's telling me that for sure I'm going to use my identity from this section. I'm going to write it as the cosine of x, cosine of y, it's plus, so we're going to go minus, sine x, sine of y, all over sine of x, sine of y. Now don't you even think about getting tempted to cancel off the sine x, sine y. Can't ever, ever, ever do it. You can only cancel when everything's fully factored. And we don't have products up here in the top of this fraction. We have some products, but it's all connected by a minus sign. We don't have a grand product, so we can't do that. Which is okay, because if we look over here to the right side of our equation where we're going towards, is that we want to actually make 2 terms. Right now I just have one fraction. If I have one fraction, I want to eventually make 2 terms. One term being cotangent x and cotangent y, and the other term being 1. Then I want to split this fraction up. I have cosine x, cosine y over sine x, sine y minus sine x, sine y over sine x, sine y. Okay, well, how you're going to match these up is you always match angle to angle. So cosine x over sine x, cosine y over sine y. Well, cosine over sine is cotangent, and that common angle is x. Cosine over sine is cotangent, common angle is y. And then sine x over sine x, sine y over sine y is 1. And look, I can cancel those off because it's sine x times sine y, sine x times sine y. So I've got a product there. That's why I can cancel that off. And we got our right side, so we can call that one done. Here in 6b, I have 2 fractions. I want to make 1 fraction. So let's get a common denominator. The common denominator, when they're unique or when they're different, you just multiply them together. Okay, so sine of 8t and cosine of 8t. This first fraction already had a cosine of 4t up there, and it's missing the cosine of 8t. The second fraction already had the sine 4t there, it's just missing the sine of 8t. Okay, so let's keep going. We got our common denominator, but let's go across the top. We've got cosine of 4t, cosine of 8t, plus sine of 4t, sine of 8t, all over sine of 8t, cosine of 8t. Okay. Well, let's go to our answer. The denominator looks great because the denominator says it should be sine 8t, cosine 8t. I've got sine 8t, cosine 8t, so the denominator's done. All I need to show is that this numerator is the cosine of 4t. Okay? Well, I've got first angle matches with first angle, second angle matches with second angle, cosine, cosine, sine, sine. Alright, so the formula says it's the cosine of my first angle and my second angle. Since it's a plus sign here, it's actually going to be minus sign here, over sine of 8t times cosine of 8t. Well, 4t minus 8t is the cosine of negative 4t over sine of 8t cosine of 8t. And I'm almost there. I have a cosine of a negative 4t. The problem says I need a cosine of a positive 4t. So do I really have the same answer? Alright, let's go to a certain part of your notes that you just saw ahead. Just one. You see at the beginning of this lesson, what did it show you right here? That the cosine of a negative angle is the same thing as the cosine of a positive angle. The sine of a negative angle is the negative sine of the positive angle. And how I memorize this, or remember this, is I pretend like, okay, negative angles, remember they refer to starting at the x-axis and going down. Well, if you start here at the x-axis and just drop down just here to quadrant 4, look, all your x values here are positive. Okay, so no matter what, see how this thing still came out positive? That's why. All my y values here, though, when I drop down, what do? They come out negative. So my y value is going to come out negative because of that. Alright, so let's go back to the problem. The cosine of a negative angle actually does equal a positive angle. So this is the same thing as the cosine of 4t over sine of 8t, cosine of 8t, and we can call this one done. Alright, last two before we call this section done right here. We have the cosine of 4t is 1 minus 2 sine squared 2t. So my angle on the left is 4t, my angle on the right is 2t. Well, how can I shrink an angle? Because I keep telling you guys you can never just divide an angle off. An angle refers to how many rotations you have to give your answer. So what do I do to work with it? I need to shrink it down to a 2t. Well, we have this identity here in this section that tells me that I can write cosine as either like 3t plus t, or I can write it as the cosine of, 4t would be 5t minus t, or I can write as the cosine of, like, say, 2t plus 2t. So which pairing do I go with? Well, I'm going to go with actually the 2t plus 2t because the angle on the right is a 2t. Okay? So let me erase all of these other ones just for a second because they really don't matter to us. And let's start with the 2t plus 2t. So cosine of 4t, we can write it as 2t plus 2t, and let's do expansion. So we want to go cosine of the first times cosine of the second minus, so do opposite, so now sine of the first times sine of the second. Okay, so this is saying basically cosine squared 2t minus sine squared 2t. Right. Let's go to our answer to kind of help us out a little bit more. Our answer that we're trying to get on this right side only has sine in it. So I need to replace cosine squared with something that'll leave behind sine. Well, I know that cosine squared of any angle is 1 minus sine squared of that angle. Okay, so cosine squared 2t is 1 minus sine squared 2t minus sine squared 2t. And combining the two terms together, you have a negative sine squared 2t and negative one more of them, so a total of negative 2 sine squared 2t. And we have our answer, so we can call that one done. Okay, so going back to our original identities, just remember, whether you know it as cosine squared theta is equal to 1 minus sine squared theta. Remember, theta can be anything. In this example, we needed it to be a 2t, but it could be a 1/2 t. It could be a z. It could be z over 4. These angles represent anything. It's just the key is they have to be the same on both sides. That's all. Alright, last but not least, secant of x minus y. Over here, my angle is x minus y. Every angle on the right is just x's and y's, so that's going to help me out. I don't know a secant expansion, but I know a cosine expansion. And secant is 1 over cosine. Okay, so my first step is just writing that as secant is 1 over cosine of my angle. So it's 1 over cosine x, cosine y, plus sine x, sine y. Okay, well, let's take 2 seconds to slow down. I have one fraction equal, and I'm trying to make one fraction. In the top of my left fraction, I have one term. In the top of my right fraction, I have one term. In the bottom of my left fraction, I have 2 terms. In the bottom of my right fraction, I have 2 terms. Okay, so everything matches up. I don't know if y'all remember from the section 8.2, what to do is when you have one fraction going to one fraction, term to terms all match up, all you have to do is multiply by the same thing in the top and the bottom. Okay, so let me rewrite where we're at right now, and let's figure out what do we want to multiply by, the top and the bottom. Well, I'm going to go one of the simplest terms. If I'm starting at 1, what would you multiply 1 by to get that top? Well, obviously it's cosecant x, cosecant y. And if I'm going to multiply the top by cosecant x, cosecant y, I've got to do the bottom too. Okay, so now it's just distributing that to the top and to both terms in the bottom. And you will get cosecant x, cosecant y. And in the denominator, when we multiply these out, okay, I'm going to write these out term by term real quick. Cosecant, oops, hold on, let me start out with I'll start out with the cosines there. It doesn't really matter what order, but we'll just go and do that. Cosine x, cosine y times cosecant x, cosecant y plus sine x, sine y times cosecant x, cosecant y. Okay, really huge fraction going on here in the denominator. My top checks off though, it's good to go. I want it that way. Let's match these up here on the bottom. Sine x times cosecant x. Well, x to x, what's sine times cosecant? They're reciprocals, so it's 1. Sine y, cosecant y. They're reciprocals, it's 1. So all of that right there is going to be a 1. Okay? Over here, matching x to x, what's cosine and cosecant? Let me write this up here, right here. If I take cosine x and I want to multiply it by cosecant x, okay? That's saying cosine of x times 1 over sine of x. So we're kind of do a little side work up here. Well, cosine times 1 over sine is cosine over sine, and we know cosine over sine. That's cotangent x. So these two pairing right here make a cotangent x. The y's, when paired up, make a cotangent y. So all that goes away and gives you this. So the top of the fraction is cosecant x, cosecant y, which matches up. This bottom left is cotangent x, cotangent y, and that matches up, and the right side's 1. So we can call this one done.